through the next naming question, and that is number 9. And let's see what it says. The last naming question in this tutorial, and you'd be done with the naming questions. You can look at the other things. So what is it that it says? It says write expanded formulas for the following compounds. Remember, it's naming and drawing. So they can give you one structure and they ask for the other. So they can give you structural formula and ask for expanded formula, expanded structural formula. They'll give you the condensed one and ask for the expanded, or they can give you whatever they give you. Whatever they give you. But when it comes to representing things, like drawing things and representing their structures or naming them, is section 1. So what is it? Yeah, they're saying for the following compounds and name them using the IUPAC system. Okay, so the first one which they've given us is IPRCl. Now you have to be familiar with this, and this section comes under the section of the naming of branched chain alkanes. So if you're not good at it, you can brush up, but I'll just give you a summary as well in this video. And for naming of branched chain alkanes, we have alkyl groups that can be attached, right? Alkyl groups, these are just a bunch of carbons and hydrogens that can be attached, and we can have them be attached in a specific way. So let's talk about some of them, and it is very important. So when you're talking about alkyl groups being attached, you can start by having one alkyl group, which is one carbon and its hydrogens being attached. And here, this is what we'll call the methyl group. Okay, so this we just call it methyl, and in abbreviation sometimes you may see it being Me. Just like you saw the IPR, you can see it be Me something. Okay, now you can also see the two carbons. When you have two carbons being attached, in other words, they are not in the parent chain, they are side groups. Okay, something like this. This would be ethyl. Okay, and in short, you could see it be a capital E, a small t. Remember, it is for ethyl. It's to tell you that you have an ethyl group as a side group. And what happens is, sometimes we like to show its bond line structure. What it looks like, it'll be something like this. Okay, this is the bond line, and you can show that this one had two carbons. Then you can show that this here is something like this. This just tells you that this last bond, don't count it here, this last one. So we'll be having a carbon here and a carbon there. There are two carbons, and in here we have nothing. They sometimes write it like this and put an R to show you that there's a carbon and a carbon, and here there is nothing. That's your ethyl. They just show the third group, the third bond, just to show it who is bonded. Then you can have 3. So this is when you have one carbon. This is when you have two carbons. Now we'll see when you have 3 carbons. Okay, we want to see when you have 3, and we'll see when we have 4, and we'll be done. So for 3, you'll be having a C. You can have it like this: CH3, CH2, CH2. Then you are attached. So basically, on this carbon is where you have, on the first carbon is where you're going to have your attachment. Now here, this would be 3 carbons, so we call this propyl. But now you should know that there is not just one type of propyl. We have 2 types of propyl groups, and this one is called the normal propyl, where you are attaching to the very first carbon. It's called N-propyl, and in short it will be NPR. Just like here in short we had IPR. Now because that is the other one. Now the other one would be, instead of having the bond be at the carbon at the end, it'll be at the carbon in the middle. So it'll be like a CH3, a CH, and this is where the bond is. Then here is a CH3. So it's right here. And when we show it as bond line, you must be able to show it as bond line. As bond line, it'll be like this. You show one, okay, or you could show it like this, going up and going up, and then you put the third bond like this. It forms like a Y. Okay, then you put zigzags to show that this is not a bond. Okay, this is where the connection is. This just tells you that this is where the connection is. This is the bond which is connecting. There is no carbon here. It is connecting to the parent chain here. Okay, so if we talk about the carbons in the substituent group, it's going to be 1, 2, and 3. That is why it's a propyl. Okay, and when you have it form a Y like this, even though the carbons are only here, you can have it form a Y shape, but only the carbons are only here, 1, 2, and 3. So this is what we call the isopropyl. This is called the isopropyl. Okay, our normal propyl and N-propyl, when we show it like this. It'll be 1, 2, then 3 like this. And on the fourth one, you put the thing like that. Okay, on the fourth one, you put the crossing thing like this. This is the normal propyl, which is part I. Okay, you can put it in dots like this. This is going to be N-propyl. Then the second one is going to be isopropyl, which is in short IPR. So this just tells you that whatever is coming to bond is going to come bond here. Here, whatever is coming to bond is going to come bond here, and it will be having 3 other carbons. You see what it is like? It's not that hard. Then we go to 4. So isopropyl makes a Y shape, but on the other part of your Y is where the thing is coming to fit in. All right. Now we are going to say for butyl, okay? Let's put butyl. We have, remember, N is normal, just the normal one, okay? Nothing unique. It's just bonded at the first one. That's the same thing you have if you have butyl. You can have a CH3, CH2, 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 and a bond here. This is your normal butyl, and we call this the N-butyl. Okay? We say N, then dash butyl. So you say N, just like for isopropyl, you can say isopropyl or you can say I.propyl. This also means isopropyl. In short, in abbreviation, it's IPR. Here we have N-butyl like this. It's N-butyl, and in brackets, and in abbreviation, it is N then BU. Okay, so we already see where the IPRs came from. It came from isopropyl. So it's isopropyl, then chlorine. Okay, so it's now isopropyl chloride. Here we have the N-butyl for the normal butyl. And what do we put here? Well, we just put the bond, so it'll be like this. So you say 1, 2, then 3, then 4. So it's now 4, and the 5th one is the one which is connecting to something. So you say 5. This 5th one is just connecting to something like this. This 5th one is connecting to something, and this is your N-butyl, and it's NBU. Now, butyl has 4. This is the part 1. Part 2 now, 4-2 is when you have it bonding on the secondary carbon. Okay, here it is bonding on the primary. You can have it bond on the secondary. Remember, when we say it's bonding on the secondary, it's like you just have CH3, CH2, 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 then you have your dash. Then on one of the secondary carbons, you put it like this. Did you see that? Just like for here, can you see that the propyl, you need to put your 3 carbons here, you need to put, so make sure you put the 3 carbons first. So just like for iso, how did we do it? You can put your 3 carbon chain to show that it goes like this. This is a 3 carbon chain. Then you put your iso, which goes onto the secondary thing. This is the iso, this one. This other bond, which I've put in yellow. It goes onto the middle thing. That's why it makes a Y. Just like here for normal butyl now, it goes right at the end. That is where the bond is. Here you still have 1, 2, 3, 4. You can see your 4 carbons. So this is what happens. You have your 4 carbons and a dash, but the dash is now here on a secondary carbon. Okay, not a but the dash is now here on a secondary carbon. And this is now going to be called sec-butyl. Okay, so it's going to be called sec-butyl. Sec-butyl, yes, which is S-BU. That is for sec-butyl. Okay? Now we go to the other 2, which is for iso and for tert. So butyl, there is the normal one. Then when you go to the secondary, it's called sec-butyl. Okay? And if you want to see it as a bond line, this is where you got to be careful on bond line. What happens when it's a bond line? You first put your 4 things. So it's like this: 1, 2. So you say 1, 2, then 1, 2, 3. Okay, it's 1, 2, 3. Then you put the 4th one coming up like that. That is what happens. Okay, this is your butyl. 1, 2, 3, then 4. Okay. Then here is where you are going to put the bond which breaks. You make it go bond here, and you make a bond which breaks. Okay, and this is for your sec-butyl. So for your sec-butyl, it'll be like that. Okay, remember to do it like that. Then here, that is for sec-butyl. Then for the 3rd one, it's going to be now tert-butyl. We can start with iso, and then we do tert. Secondary butyl, you saw it's on a secondary thing. Okay, then for iso, what is it going to be like for isobutyl? Well, you can show it like this. They show it like CH3 and 2. Then you say CH, then CH2 dash. So what happens on your isobutyl? Well, and how does it change from this other one? Well, how it changes is, well, you're going to have your structure having 3 carbons in the longest chain. So it's going to be like this: 1, 2, and then this is like 1, 2, 3, right? These are 3 carbons in the longest chain. Then we come here, we put another thing like this. Then the bond is not going to be, so now we have 4 carbons, right? Then the bond is going to come at the end and put itself. And this is going to be your isobutyl. Okay, the bond will come at the end and put itself, so it's like it's going to come, and this is going to be how you have your can you see the difference? Can you see the difference? What is the difference? Well, let's put the difference. For secondary butyl, we had it as 1, 2, 3, then 4, a chain of 4 carbons, then the bond came on the secondary, right? Here we have a chain of 3 carbons, which is 1, 2, 3. Then we have a substituent. Then we have this being the other substituent, and it goes on to the first carbon though. Okay, now we'll do the fourth and final one, which is going to be, I know you've done a lot. It's going to be like this, CH3, and there are 3 of them, and it's going to be C. Okay, so, maybe let me close this off. This, remember that this is going to be isobutyl. So either for iso, either it's written in full to say isobutyl, only for iso, or it'll be I-butyl. For isobutyl, it's I-butyl. Okay, which is going to be IBU. Okay, IBU in abbreviation. That is what it's going to be. Then for tert butyl, you can see here, it's just a tertiary one. And actually, just like for iso, the longest carbon chain is not 4 carbons, but it is actually 3 carbons. So you can say the longest carbon chain is like this. Okay, 3 carbons. Then you can put another one which comes in between like this. Then this is how you have your 4 carbons. Now you can show the other bond, which is just the bond which goes out like that. Okay, that is going to be your tert butyl. Tert butyl. Okay, which is going to be, or you can say T-butyl. Okay, which is going to be TBU for tert butyl. Can you see that? Then these are all your things. Then finally, you put the last one, which is just a phenyl group. It is the last one where you have a benzene ring as a side chain, C6H5. And what you just do, you show your benzene ring. You know your benzene ring, right? It's a hexagon. So it's 1, 2, 3, 4, then 5, 6. Then you can put your benzene ring. It is a bond here. You can put another one and another one here, right? Then what happens is here is where you are going to have it bonding out. Remember that don't count this one, the one that comes outside, as nothing there. Don't count them. There's no carbon, there's nothing, but you count behind it here. Like here, I have 1, 2, 3, 4 carbons. Okay, you see that? And what about for the other ones? I had 1, 2, 3, and 4 carbons. You see it makes the letter Y? You see here it makes a letter W like a V inside. Then here you can see it makes a square U like this. And then the bond comes out. So this is what happens. You make a square U and the bond comes out. That's for sec. For iso, you make a Y and the bond comes out. That is for butyl. Then for tert butyl, you make a 3 and the bond comes out. Then for the first one, which is the normal butyl, you just put all 3 of them. Okay, so 3, then a U, square U for sec, then a Y, then a WV. That is what happens. And this is all you gotta know. Okay, and here we say that this is going to be your phenyl, and you see in short being a pH, phenyl. Then tert butyl is TBU, then IBU is isobutyl, then SBU is sec butyl, then NBU is normal butyl, then isopropyl, then just the normal propyl. So don't ever forget this. Do it again and again until you've mastered. And now we're going to answer this question again, which is number 9A in the next video. Goodbye for now.